Thank you, Vishnu sir, for throwing light on the various initiatives and innovations of NIC on the pillars of geospatial technology and for sharing with us a way forward for the entire industry. May I now invite on stage Dr. Manoj Khare, Senior Director and HOD CDAC. Currently, Dr. Khare is heading the Emerging Solutions and E-Governance Group in CDAC Pune. He has 29 years of experience in GIS, remote sensing, and photogrammetry, and has been involved in more than 20 projects of national importance. Welcome, sir.
So, good evening, everybody. And I thanks AGI for giving me this opportunity to interact with the geospatial community and some of my old friends. So, I'm from CDAC. So basically, CDAC comes under the Ministry of Electronics and Information Technology and carry out research in ICT, and electronics and associated domains. Okay. So CDAC works in the high performance computing, artificial, multilingual, and geoinformatics. So in CDAC, my group is Emerging Solutions and E-Governance Group, basically works in the GIS, and we are working for the last 25 years in geoinformatics and developed various solutions for state and central government departments. We work in the disaster management, hydrological studies, G-governance. We are also working in the signal, image, and video processing. Okay. So from the today morning, many speakers have pointed out that now I think each and every organizations and domains are using geospatial data as well as geospatial applications. And a lot of geospatial data like high resolution images from the satellite, drone, LIDAR, vector data, and a lot of sensor data is available. Okay, so to cater the needs of various users, there is a requirement of advanced service of data acquisition, interoperable data at one place, but here 2 points I would like to identify. One is the faster data processing, because many geospatial projects now using the forecasting data. It may be for weather data, flood data, and for forecasting data we require simulation and modeling, and this requires a lot of high performance computing resources. And second thing I wanted to point out, like a high uniform standard operating for not only for data, but for the modeling, DSS, also, so that we can basically save a lot of ICT and money. If suppose, for example, if we have a standard operating procedure for the smart city, even for the data, method, modeling, scientific, so then we can save a lot of money and we don't have to afford, we'll have to less support. Okay. So now I will just show some of the project, CDAC project, which we are doing using cloud computing and HPC resources. So one of the project is urban modeling. Under this project, basically we are doing the coupled urban meteorology, hydrology, air quality modeling, and GIS-based decision system. Now here I like to point out why we are coupled. Now, if you might have observed recent times, a lot of this extreme weather event has increased multifold. Like we have a high intensity low duration rainfall, then temperature, lot of temperature increase. Even in Pune, last week we felt heat wave, which we have never felt in Pune. Then a lot of pollution, hotspot is increasing. And each events, this weather events have a cascading effect. If you have a heavy rainfall, because of that there is a flood is coming. Similarly, if you have a low temperature, sometimes pollution is increasing. To study the in total, we have to go for the coupled modeling. So we are doing the coupled modeling over here, and the partner in this project are ISC, IIT Pune, IIT Bhubaneswar, and IMD. Initially, we are implementing in this project in 5 cities: Pune, Bangalore, Bhubaneswar, Ahmedabad, and Delhi. Okay, so this entire system is a cloud-based system. So if you see, we have one of delivered urban database management. So it's basically cater the needs of all the urban environment data and GIS data required for the urban city study. Second is the HPC enabled automated coupled model framework platform, simulation platform. So here basically what we are doing, we are developing an automated framework. So small cities, they don't have to bother about the HPC, they don't have to bother about the script, but they can log into the system, can use their data, do the modeling, and utilize that result in the DSS. And the third basically output delivered is the decision support system, so GIS-based decision support system, and so that it can be used by policymakers, citizens, and other people also. So through basically the system, we are providing services in the hydrology, meteorology, and air quality in the first phase. Later we will go for other factors. and users are the various government organizations they are using over this data. So point here is this kind of project is required high computing resources. If you see right now, the WRF model, the weather model, if we go for 1 kilometer resolution, so we are, if it is laying in 25 nodes, and basically it's taking around 750 minutes, but to process data is very efficiently and very fast manner, so that they can be utilized. At least we can give a near real-time basis. So we have required a lot of resources. If you go for if you want to give the world level forecast, then we'll say for 5 meter resolution, we require around 125 nodes, and around 5,000 core, so that we can process data in 45 minutes. So this is talking about the Pune. So you can assume what kind of resources we require for process of this data. Okay. Next project which we are working in the early warning system for flood prediction. So we are basically project is early warning system for prediction in the river basin of India. Currently, as per our user agency Central Water Commission, we are working in the Mahanadi basin, and along with the river forecasting, we are also integrating this system with the sediment transport model to basically to know the river carrying capacity of river, as well as the integrated reservoir operation tool, so how to plan, so that they can plan the water release, so that it will not affect flood in the downstream, and decision support center. So basically output which we are giving the 3-day river forecast, inundation max and water level forecast, and village by percentage inundation information. Here is Central Water Commission. So here also which I went, the kind of this flood forecasting require a lot of simulation. This benchmark which we have done in the Mahanadi basin, that too only for the delta part of the Mahanadi basin, which is around 9,000 square kilometer. So if you go for if you go for 4 hours if you generate a forecast in 4 hours for 3-day forecast, it will require around 45 nodes. Okay. So now this I am talking about the only 9,000 square kilometer. If we go for the entire Mahanadi basin, which is around 1,43,000 kilometers, we will have to require 4 petaFLOP machine. And if we go for the Ganga basin, which is around 10 times more, it will require 40 petaFLOP machine, single beta. Now, if you see, we have around 20 river basins in India, and out of that 4 are basically river flood prone, like Brahmaputra, Ganga, and Mahanadi, and other basin. And most of the time flood comes during the monsoon season. So if we have to run the forecasting model in the R river basin simultaneously during monsoon season, you can imagine what kind of resources we'll have to require. So there's a need of a lot of high performance computing resources in this kind of project. And another project, third project which we are working, basically we are development of fire spread model. So here are basically this project we are implementing Sikkim. So there are 2 components there. One is the normal GIS project. We are getting data from FSI through SMS, we are bringing into GIS and then query elder. Second is the most important component of this project, the coupling of weather, fire and commutation CFD model for fire spread simulation. How fire will spread, that we are going to give it. So this kind of this kind of project is also require a lot of computing. If you see here in the first table, if you see, we have a running simulation time only for 16.6 minutes, and we are using 3 nodes. At that time, it is taking 24 hours to simulate. If we go for if we increase the area, or if you increase the time, or suppose we want to go for 2.6 hours simulation, then it is taking 40 nodes, and time is taking 40 hours. So that's why I'm saying that this kind of project requires a lot of computing resources. Okay. Now I'm talking about the glacial lakes, the project which we have done in the Sikkim. This is the glacial lake mapping and early warning flood system, which we have developed system. We can say most probably it is India's first indigenous GLOF early warning system, which will install at Sikkim. So under this project, first what we have done, mapped all the glacial lake of the Sikkim from the satellite imagery. Then we have our CDAC Tremendum office developed a sensor to measure the water level. So this water level this sensor has been deployed 2 lakes in the Sikkim, and the sensor which transfer data on a real-time basis to the INSAT satellite to the control center, which is a DST Sikkim. So idea is this sensor, we are getting continuous water level information. If there is sudden drop in the water level, then system will get activated and simulation will start. Then simulation will give the inundation information and flood arrival time downstream villages. So this project is also required a lot of computer time. If you have more, suppose you have a 2-3 flood GLOF event together, then we require a lot of computing resources to process the data. Okay. Now we are also working with the Prime Minister, this Ministry of Rural Development, and we have developed this Geospatial Rural Road Information System for the PMGSY roads. Okay, so this is the public hosted site. It's a lot of GIS data is available here, and various kind of query you can see, which is the village which is connected, which is the habitation collected, population wise, which road is connected, which road. Okay, so while working this project, NRDA wanted to have an online geospatial transaction system, so they can edit data online, they can approve the project online. So this was, so for that we have developed a software called GeoSadak. Basically, it's development open source technology, and it also uses the ISRO Bhuvan Satellite Data Service. It's aligned with that. So it's a model which we have upload and approve. So we can, like, this is only for the PMGSY officials. They can upload data. So like state, suppose somebody wants, some state has prepared any GIS data, they can upload data, then admin who is sitting in the center level can approve that data. They can do, then they can generate the QC report on based on this GIS data also, whether it's this data is available MIS or not. One thing I just forget to mention, because this project which I just mentioned, GRIS is one of the successful story of MIS GIS linkage. So whatever data we are using in MIS data is coming from OMS, which is also developed by our e-governance group CDAC. Okay, so this QC reports check whether this road is there in the map, but it is same data is available in the OMS or not. This kind of QC can generate. Then another thing is edit of the data. So online edit, they can just see, they can edit the data online. They don't have to go to the GIS software and edit data. Online they can edit data and update the data. Then state report, state report can be generated, how many project has been come, how many data is loaded. Similarly, we can go for a national report. Then the facilities trace report, we are just going for develop this, so they can click on 2 points and automatic road layer will be generated. Then data service, so data service, like they can call Bhuvan data, open source data on this map, and they can see the data. Then data visualization is there. Then download, you can download the data, whatever data is available. Then proposal, so here we can see the proposal. They can check whether the alignment is correct or not. They can, if they are not correct, they can edit the proposal itself, and they can be again. So this is basically, this project is being, this product is being extensively used by all the states for the PMGSY road. Now, so now under the PMGSY, a lot of data was generated by PMGSY or state and government. So now, as per government of policy, this data have been made available to the public. So in the it was launched for 22nd Feb last, honored by Honorable Minister of Rural Development. So there's the open data. You click on the open data, then this kind of thing, then you can download there. Initially, it has only 4 layers. Now slowly we are increasing only there. Now, so because if you see the GeoSadak, it was only for the PMGSY. Now we have developed another project called GeoCivic Field GIS. We have launched on this Friday only, and it has this project is useful for the smart city, land record, asset mapping, taxation. All this can be used. Okay, so this GeoCivic GeoSadak is only for PMGSY. Now GeoCivic is a generalized project. All other domains or theme areas can be used this project for the online editing of the data, proposal finalists, everything. Okay. So like if I say earlier also, like a lot of now many GIS users is increasing day by day, and many projects are using this forecasted information. So before, like cloud enabled geospatial information and modeling and simulation using high performance computing. Thank you. Thanks for giving the time.